Hey, what's going on, guys? Today we're going to be training a neural network on this data that we have here, and we are going to be helping the neural network classify the sentences we have in the input according to the output. I'm going to start doing this by first of all mapping out and transforming the training data. So we're gonna go X of each training data, and I'm gonna say I want to construct the input. Okay, so I want to encode the input, and what I mean by encoding the input is I have to find a way to transform the input into a way the neural network is going to understand. It's not going to understand these letters. It needs to understand numbers. So one of the ways we can do this is we are going to be finding the each character in this sentence. For example, for example, we are going to be looking for the character code, which is ASCII code. We're going to be finding the code, and then we would divide by 256, which is the maximum of codes that we have in the ASCII. So I'm going to be saying x.compute. First of all, I'm going to split this. Then I'm going to do the same thing we're doing to this training data. I'm going to map each of the character. I'm going to get the character code at 0, and I'm going to be dividing that by 256. I think 255 is fine. It wouldn't cause any issues. Then for the output, I'm going to say the output is going to equal to, if we have happy, if the output is equal to happy, we want to tell the neural network to identify the input as a number. So we're going to be doing a binary classification. What that means is for happy, I'm going to say 1. Then for sad, I'm going to say 0. If we had like multiple classes of this same output, it would look something like this. Happy 1, sad maybe 0, and depending on what we have, neutral 0. So let's say we had 3 classes rather than just happy and sad. We would be constructing it like this because we would still want to classify between 0 and 1. Okay, so I'm going to delete this. And now that we have our input encoded into numbers and also our output, we are going to be returning input and output. Cool. The next thing we're going to be doing is we are going to be bringing in our neural network. There is a good JavaScript library on GitHub that lets us do this. It's called Brain.js. We can do all sorts of training. We can use autoencoders. We can also use recurrent neural networks and use LSTM, long short term memory. We want our neural network to remember the input data we're training it on. So let's go. I actually got the example for this lesson from the documentation page. This is it right here. But in this particular document, they used a recurrent neural network, which is ALSTM, but I'm not going to do that. I'm just going to use a regular feed-forward neural network. Okay, so in the terminal, to add this JavaScript library, make sure you have Node.js installed. For me, Node.js and NVM installed. For me, I'm just going to be switching my terminal to use 16. So this is going to be using Node version 16, and the reason why I'm doing this is the most compatible version of Node that makes installing the library easy. Okay, if you use anything above this, I can guarantee you have a smooth process installing this library. So this should be done in a couple of seconds. While that's running, it's done. We're gonna close the terminal and we are gonna be saying, actually, I'm gonna comment this out. Let's open our terminal and let us. Oh, it's fine. Let's just continue. Let's initialize our neural network, and we're going to say new brain. Actually, let me go into the package.json and let me define a type model. This would let us use import statements in our JavaScript code. And I'm going to say import brain from brain.js. Okay. So now that we have the library, I am going to be using. So this AE stands for autoencoders. We have cross validate. We have a feed forward, but I'm going to go for the regular neural network. You know what? Yeah. Then I'm gonna be running train on this neural network. Actually, for the Python developers, we are going to be renaming this to fit. Makes it kind of easier to grasp. And I'm gonna say neural network.fit. And that training data, then I am gonna be testing this neural network and output equals, and then predict. It doesn't have a predict. Okay, but I'm gonna be creating one now. I'm gonna say, and then the predict is equal to, and then the run. Okay. In here, I'm going to be testing our training data. The first one, I'm gonna be grabbing the input. So this should log happy, which is 1. So this should say 1 when we run it in our terminal. I'm gonna log the results. Output and output. I'm gonna grab the first item and it returns an array, so I'm gonna grab the first one, and I want it to be fixed. Okay, so 0. I don't want decimals. Just want to see 1 or 0. Then I'm gonna convert this back into a number. Okay, now let's run our code. Okay, cool. So we have this error. It says input at index 1's length is 30 and the one at 0 is 29. Okay, so this is common for neural networks because all neural networks, or maybe just this one, require a fixed input size. Okay, so what this means is if you look at the input we have here, the amount of characters in string is 29, this is 30, and it's like, you know, things are not matching. How we are going to be fixing this is we have to have a fixed token space. Okay, so we're going to be having a fixed token space. So for this, I'm going to be saying token space is equal to, we can make it 30, which is the maximum length of input we have here, but we'll say 40. Cool. Then we are going to be looking at the amount of blanks we have in an input. So for example, if our input contained 5 characters, which we've now encoded as numbers, those 5 characters would come first in our input data, then we would fill an additional 35 characters with zeros. So that's space. You can expand the amount of tokens you can have in the input, and also do some advanced stuff like generation. But for this one, we are going to be doing token space. Then we're going to be checking the amount of blanks we have. We're going to create a new array based off that. Then we're going to say token space minus input length. Then we're going to be filling this with 0. So this is an array filled with zeros, and it's based off the inputs, the amount of characters in the input, and our token space. Okay, so we are going to be restructuring the input to have in those blanks, and I'm going to say blanks. Okay, so now if we run this code, our output is 1. Okay, so for the first one, at index training data 0, I feel great about the world. It's happy, and remember, happy means 1, so it says 1. Okay, so let's try the second one. It should say 0, which is sad. In the next part, we are going to be using an external data set. We are going to be reading and transforming the data set. We're going to be applying what we've learned about encoding and token space. We're going to test the model on validation sets rather than the same training data we used. We are also going to be getting the accuracy of the model on data it hasn't seen before, and we will be saving the model for reuse in the future. So this is all going to come up in part 2. Watch out for that.